UniversalAutomation.org is a non-profit independent organization, and we drive the adoption of a common automation layer among vendors.
This common technology is called a runtime execution engine. This technology is enabling companies to decouple the hardware from the software.
So the key point is in the past there was one hardware with one task, okay, working perfectly, no problem. But we need to keep on going. We need to evolve, which is the evolution. The hardware can have a different kind of software and everything can run on top of this.
The main benefit for end user is that they can design in a software-defined automation way more cost-efficient automation solutions. First, they design the software layer, the control application itself, and only then they choose the best fitting hardware pieces despite the vendor.
That is what universal automation is all about. You're gonna have a lot of companies able to deploy solutions over the IEC 61499 standard.
There are so many devices, but there is just one technology which is shared amongst all the hardwares. So an engineer can get the chance to create an application, create a software, create an object, and it can deploy on any devices in the expanded world of industry. The companies and end users that are starting this journey of universal automation now, they're building a competitive advantage because they're able to have applications that are reusable, they have modularity, and this means that they can scale up and down their operations, they can simplify their operations and streamline them. And that's huge in the current market situation.
Hello everyone, and welcome to this new edition of UAO Goes Live. Today, automated well-buyer tests with IEC 61499. This is the topic of today. My name is Greg Bucco. I'm the Chief Marketing Officer of UniversalAutomation.org. And today we will explore how IEC 61499 and UniversalAutomation.org technology are being used to orchestrate well-buyer tests in offshore environments. This process is essential for ensuring safety and efficiency in oil and gas operation. And Kongsberg Maritime has taken a major step forward by leveraging software-defined automation approach. I'm delighted to be joined by Merete Gotas and Karin Karadenis from Kongsberg Maritime, who will share their insights on this innovative solution and what it means for the future of automation in the energy sector. Please stay tuned and feel free to ask a question during the chat, during the whole live, in the chat, using the Q&A section, or directly on LinkedIn. So let me welcome Merete and Corinne on the stage. Hi Merete, hi Corinne. Thank you for joining us for this session of today.
Thank you.
I will give you enough time to audience. Please go ahead. Merete, you want to start?
Yeah, thank you. I'm Merete Gotas. I work in Kongsberg Maritime as a department manager. Our department are exploring new concepts within our control system for energy production, and especially within oil and gas installations on the Norwegian continental shelf.
Yes, hi, I'm Corinne Karadenis,
Corinne.
and I am a member in Merete's department. So as you said, our job is to explore new concepts, but my main purpose is to explore the implementation of these concepts. So that's been my main focus in terms of IEC 61499 and server-side applications.
Great. Let's see what you have for us. I think you have brought some great presentation, and let's diving into it. Let's see a bit more about who is Kongsberg Maritime and what you've been doing with the 61499 and UAO technology.
Thank you, Greg. Corinne and I are very excited to have the opportunity to present our solution on automated well barrier test based on universal automation and IEC 61499. Just to give you some context of our company, we work in Kongsberg Maritime, which is part of the Kongsberg Group. We develop new technology from the bottom of the sea to the outer space. Kongsberg has 4 business areas: Kongsberg Maritime, where we belong, and then we have defense, digital, and discovery. We are about 14,629 employees, and we are represented in 40 countries, and we have a revenue of 48.8 billion NOK. Then, in Kongsberg Maritime, we develop and supply technology which help realizing a sustainable management of the ocean space. We are about 7,250 employees. We have a revenue of 24.8 billion NOK, and we are represented in 34 countries. We have our system and technologies on approximately 30,000 sailing ships and fixed installations. So, our department is focusing on 2 main concepts right now: operator environment and preparing for remote operation. The operator environment is very important, and we are also offering this integrated workstation for secure collaborative operations. To utilize and combine our Kongsberg control system and the integrated workstation, we offer control applications in the server layer, which is our topic today. Our control system, as you see up in the left upper corner, has 3 layers. And the real-time layer with the controllers and the server layer, they both reside in the OT domain. All data from the controllers is available in the server. And we wanted to add value to those data. We wanted to automate operations and improve HMI. And the answer to us was universal automation and IEC 61499. We are allowed to automate the operations, i.e. open and close valves from the server layer, since we reside within the OT domain. All the results and data are reported to the IT domain for further use by the owners and the management. We call our applications in the server-side application, and it really makes engineering, installation, and maintenance easier and more efficient. We also do this without interrupting the real-time system itself, no interruption to the process controllers, and we also reduce the load on the controllers by utilizing the server. So then over to you, Corinne.
Yes. So a bit about the IEC 61499 standard itself. It's about, as was mentioned in the run-up video, to decouple hardware from software and also a more open architecture. But for users and also some customers, what they might wonder is what is involved in this kind of switchover process. How does the mindset have to change? What might they have to change equipment-wise? And we wanted to give a little bit of feedback just based on our own experiences. So for server-side logic and IEC 61499, it's built up using function blocks. And our engineers are very familiar with function block applications. We can create new functions that can be written in structured text, as simple as structured text, or more complicated as C++. But but it means that we can have programmers of all levels that can contribute to the process. And we've also found that it's a scalable solution because we can build reusable applications from standardized procedures, and we have a standard OPCU interface for the import and export of data. It also gives us some new features enabled. We can start and stop applications. It's an event-driven execution, which means that we can control the load or the resources that are utilised, which we don't have the capability to do in the real time. And we're utilising some third-party software, which is EcoStructure. And that aligns with some of our Industry 4.0 goals. So that's just some input from our own experiences for anyone who might be considering utilising IEC 61499 and UAO. So, as Marietta mentioned, we have identified some criteria for the applications that we have created. So, in our real-time layer, time-critical functions, input, output, and safety shall remain. But what we have found quite useful in the server is non-time critical, combining data, orchestrating applications, and automating procedures. And that's what we will discuss further today. So by having this standard, IEC 61499 and UAO, we have functionality both in Kongsberg's real-time layer and the server layer. That's what we can offer to our customers as added value. And then Marietta will talk a little bit about the platform that the project will be installed on.
Yeah. So our showcase today is taken from the biggest oil producing installation on the Norwegian continental shelf, Johan Sverdrup. Johan Sverdrup is operated by Equinor and consists of 5 platforms. So this demonstrates the seamless information exchange via our control system and OPCUA. Johan Sverdrup consists of, in total, 150,000 IOs. To assist the operators and add value to the data we already have in the system, we have used IEC 61499 and UAO. And to us, it's very important that everything runs smoothly and that we build trust with the operators offshore. So we have, for the well barrier test, we have tested extensively using our Kongsberg simulator. And right now we are preparing and training the operators offshore, and they are very satisfied with the service that we have built in with IEC 61499. Preparations for installation and the service offshore has started, and Corinne and her team, they will go offshore in the beginning of November to finalize the installation and go live. And then why offshore and not remote? Because we were bragging that we could do everything remote. This is our first application doing control on an offshore installation on the Norwegian continental shelf, and this is a big milestone to us. But the next applications, they will be installed remotely. Okay, Corinne?
Yes. So just to talk a little bit about what the well barrier test is, to give a little bit of background. So it's something that's performed periodically and used to assess the integrity of the barriers or valves in a well, and pressure testing is a typical technique. Currently, or what we will be installing very soon, as Marietta mentioned, that's 5 procedures per well, which is currently carried out manually by the operator, which is many man-hours spent offshore. And what we want and what we will achieve using IEC 61499 and the KCS control system is an automated procedure which is operated by the best operator. And we want to optimize and gain that repetitive quality in the procedures for the operators. So how have we achieved that? As we've mentioned, we have our control system, which is KCS, and KCS is basically a huge information hub where we can collect the data from all our assets, we can analyze it, and we can organize it. And traditionally, it's structured as it is in the safety automation system for real-time applications. But what we've done a bit differently here is we've tried to pivot to a more object-orientated, standardized interface so that we can utilize this to switch between data sets. So we have a more functionalized or a functional model that's standardized and generic. So we have reduced configuration, we have reduced maintenance, but it also gives context and value to the data because we can export this functional model to our information system, KIMS, and also further on for further analysis to our customers. So by organizing our system, which is possible in KCS, we can do something along the lines of this. So we have what we label functional HMI. And as Marietta mentioned, one of our major goals is to improve the operator environment. And if anyone has ever been offshore or seen a standard control system in the mimics, the information can be scattered across a lot of different mimics. So it's hard for the operator to get a good overview of what it is that they're doing, when they should do something, what they need to pay attention to. So we wanted to collect all that information. But to do that in the traditional manner is difficult. But with the functional HMI and the server-side application, IEC 61499, and the modeling that we've created in the KCS address space, the operator makes a choice. I want to test well 10. The server-side application built in IEC 61499 fetches the correct data model due to this standard interface in KCS and displays the information that the operator needs. So it allows them to remain focused on the important tasks while still having an overview of the situation. So what we've also managed to achieve by doing this is, currently, but I should label it as past, for one typical, it would be 500 modules in the real time, which is additional load, 14 images just for one typical. And the outcome of that for 30 instances would be around 15,000 modules in our real-time control system and 420 images. But by utilising KCS and IEC 61499, we have also achieved a first, never been done before, functional HMI. We have one dynamic HMI, one application, and one model per well. And that is an overview of the well barrier test. Thank you very much.
Great, thank you, Merite. Thank you, Corinne, for sharing that with us. I'm just going through the chat. So for those of you listeners who are live, you can pose your question or ask your question directly on LinkedIn or on YouTube, so we can get to them, and I can ask them to Merite and to Corinne. But maybe let's start with one question from my side. So you said that you will soon, let's say, integrate these well barrier tests offshore and so on. Do you have any, let's say, expected benefits, but in terms of, for example, expect to achieve by doing this operation on a real, let's say, on a real instance, on a real platform? So what could be in terms of benefits? Which percentage are you looking for, or are you expecting, let's say?
Yeah, I mean, the main benefit for us and also for the customer is that this currently is carried out manually. And to add this into our real-time layer was going to be quite time-consuming and also a lot of load into the existing controllers. So what it means for us is by hosting it on the server layer and having these server-side applications, we can automate the procedure, which is what the customer wanted in the first place. So we are saving those man hours for that operator, that they do not have to manually carry out these tests, which can be quite time consuming and cumbersome. So yes, that's the main benefit for us. So I don't know how to give that in a percentage, but yeah.
Yeah. So basically, automating a task which has been for now manual by still keeping, let's say, a lot of the hardware which is already on site and adding a layer and managing all that with on server side. Yeah, that's
Also,
basically. Go ahead.
Also, we add some quality because for all the instances of the wells, it's done the same way.
Yes.
And also, if you need to do some changes on the HMI, you only do it one place, and it fits all. Yeah.
Yes.
Yeah. So really, by having the same way of operating on all well barrier tested, which are on all offshore platforms. So really, in terms of quality improvement, yes, for sure. It's not something that we can let's say easily mention in terms of percentage, but this is already something where we see that the quality will be drastically improved thanks to that. Yeah. Now, when we have a look, so now we kind of focus on the well barrier testing. Do you see other operations on which you could do the same kind of approach, like going from manual to automate and so on, and which could that be, for example, on an offshore platform?
You could think of all the startup procedures that they have when they're starting up or shutting down their installation. That's even bigger than what we are talking about today. So I suspect that might be the next application that we will look into.
Go ahead, man.
No, it's okay.
Okay. So basically, let's say a lot of the manual operation to kind of increase quality around that, try to automate them and to always take the best of the experience to make the best sequence. Is that a good way to put it?
Yes. And also you can think an operator has a very big responsibility. Also when it comes to timing, sometimes they have a number of timers they have to keep track of. This you can build into our applications and help them to do the right thing at the right time.
Yeah.
It can also help us because it's kind of in that server layer, it can orchestrate different tasks across different assets as well. We see that as a good possibility for use. And as Merete said, some guidance as well for the operator. You should do this, or, critical task. And these are some interesting things we would like to explore more.
That's quite interesting. And I see that actually the same question came from LinkedIn as I was asking from Arman. Is it possible to automate other procedures as well? So your clear answer is yes.
Yes.
And this is something which will be done at some point. Thank you, Arman, for your question.
We are also working on trying to implement or incorporate MPC, Advanced Process Control Algorithms, into the IEC 61499 environment. We have started to do some testing, so it looks promising.
That's quite a good outlook, and I'm looking forward to welcoming you when it's done, so you can explain us a bit more about how that went and how good it was.
Basically, we see this as just the beginning. This is just the first, and we see that there's a lot more uses and opportunities and that we can use this for. So this is just the start.
That's just the start. That's a good start, by the way.
Yes. Thank you.
That's really amazing, and that's really as well good to see and hear for the audience. I mean, this is a technology on which we are betting and we are pushing for quite some time already, and now seeing this all those use cases and you even putting these use cases from Kongsberg Maritime site, and especially on orchestration, that's quite amazing. And I was just wondering, because you are highlighting some benefits such as scalability, event-driven execution, or OPC-UA integration. Do you see others features which could as well improve the operation based on those topics, or?
We mentioned that we can make typicals so that they do everything the same way every time, and also help them so that the operators won't have to search through a lot of mimics. They only have this one mimic, functional HMI, that will give them the information they need at the time they need it.
I think we tried to mention all of the main benefits that we found. So there may be more. As we say, this is just the beginning. So I'm sure that as we grow and also UAO grows as well, there will be more functionalities that will be added as well and more improvements, because we see that ourselves. There's continuous improvement all the time. So I'm sure we will find even more benefits as we move further along in time as well.
Yes, that's quite interesting, and as we see as well, number of the community growing and people actually and companies actually investing into the technology. Let me take one question from the audience, from Rudy Deanda. Are you also considering a co-pilot for guidance to operators in real time? So we speak about, I think, AI now.
Yes. Actually, we are playing a little bit with AI, but we also have some discussions. But it's an interesting area, for sure.
Yeah, for sure. You're using already all those great applications on the server side and so on. That could be maybe the next steps.
Yeah,
maybe.
Why not?
I think what you have to sometimes. The world moves very fast, but in the oil and gas sector, it can be a little bit slow moving, especially because of the safety. It's very safety conscious, of course. And this is already a big step. So, of course, in the future, there's so many possibilities, but this is a good step towards more automation in the oil and gas sector, that we're putting these applications on the server layer and automating these for the operators. So there's opportunities in the future, but maybe not tomorrow, Rudy. Maybe
maybe later.
Maybe a couple months or.
That's already a good one. So let's move to the next question from Michel. Seems like you have a good amount of new functionality. Do you need to expand the infrastructure in any way? Hardware, processing power, etc.
No. We utilize, and that's one of the main benefits that we tried to make a point of, because we don't need additional hardware. The signals are there, and we have this in the server layer. It doesn't take up a lot of capacity, from what we've found at least. So we can utilize everything we already have. So we haven't actually found that that's a limiting factor for us, at least in Kongsberg Maritime with the controllers and KCS. So maybe Merete has some additional to that. I don't know.
No, I think good answer.
That's great. So yeah. That was already a good session, and we are approaching the end. I see that there are no other question from the stage and from the audience. So thank you all for joining this session. Thank you, Merete, and thank you, Corinne, for sharing these valuable insights on how IEC 64099 and universalautomation.org technology are transforming offshore operations. It's clear that automation is not only about efficiency, it's also about safety, scalability, and future-proofing of critical processes. To our audience, thank you again. Thank you for joining us. If you'd like to learn about universalautomation.org and how you can be part of the movement, then please visit the website give us a thumbs up, and we will contact you. Until next time, keep innovating, rewriting the future of innovation. Again, Merete, Corinne, thank you again for making it. This has been a great session, and thanks as well to Kongsberg Maritime for always being with us and helping us to grow as an organization. So thank you all, and wish you a very good end of the day. See you. Bye-bye.
Thank you. Bye-bye.
Thank you. Bye.